Hello, this is Mr. Henry, and this is lesson 3.4. Today we're going to be solving equations that have variables on both sides. We saw yesterday, or on the last lesson, that when we saw the 5 steps to solving an equation. We saw what happens with parentheses, we saw combining like terms, we saw getting rid of other terms using add and subtract, and we saw getting rid of coefficients using multiply and divide. The one step we did not see is what happens if we have variables on both sides. That's what we're doing today. So before we get into the lesson, let's just quickly try these 4 get the goose. So to get rid of parentheses, we distribute. Negative 6h minus 4 equals 8. I'm going to add 4 here, add 4 there, out of space. Negative 6h equals 12. Divide by negative 6, divide by negative 6, and h should equal a negative 2, because a 12 divided by negative 6 is negative 2. So we were close. Number 2. First things first, I see we've got parentheses, so we distribute. Get 2r minus 6 equals 8. We'll get rid of the add and subtract. So we're going to plus 6, we get 2r equals 14. And then we're going to divide by 2, and these cancel. R equals 14 divided by 2 is 7. Number 3, ooh, we even got some work in number 3. Number 3, let's see. Their first step they try to do is plus 9. Wah, wah, no. The way you get rid of a plus 9 is with a minus 9. So then 21 minus 9 is not going to be 32. 21 minus 9. Oh man, it's early in the morning. 21 minus 9 equals, there we go, 12. And then we divide by 4 on both sides. These cancel. M equals 12 divided by 4 is 3. Okay, last of these, parentheses, distribute them. We got 3b plus 15 equals 6. We're going to subtract 15 on both sides. These cancel out. We've got 3b equals 6 minus 15. Well, we'll pop in our calculator, I guess. 6 minus 15 ooh, that's not 15. 6 minus 15 equals a negative 9. This is a times by 3, so we divide by 3 here, divide by 3 there. They cancel. B equals a negative 3. So we were kind of close on 2, we just had our signs wrong, and we were pretty far off on the other 2. Alright, so today we only have one new vocab word. We have this word called identity. What an identity is, it's an equation that's true for all values, where all real numbers will work. Now I can give you a simple example of this. 2m plus 1m equals 3m. Now, no matter what number you plug in for m, this will always be true. If I put in a 4 for m, 2 times 4 plus 1 times 4 might equal 3 times 4. Let's see, 3 times 4 is 12. 2 times 4 is 8. 1 times 4 is 4. Add it together, you get 12. Okay, maybe I got lucky. Put in 0. Well, 2 times 0 is 0. 1 times 0 is 0, so this side equals 0. 3 times 0 is 0. What about a negative? 2 times negative 5 plus 1 times negative 5 equals 3 times negative 5. This side is negative 15. 2 times negative 5 is negative 10, plus a negative 5. Negative 10 plus negative 5 is negative 15. So this would be your identity equation, where every single number will work. We're going to see these later on today. Now, one thing you're going to notice about these equations is they are quite a bit longer. There's just more stuff in each problem. Now, before we go through too far, let's quickly write down our 5 steps again. So, on your paper, on the back, in your note, on the vocabulary box, if you got space, someplace. 1, 2, 3, 4, 5. Write down your 5 steps from memory if you can. If you can do this from memory, it means you remember what's going on. If you don't remember them, that means you don't remember what's going on. What are the 5 steps to solving an equation? I'm going to go through them now. I would recommend you pause the video and try to do them all for yourself first before you hear me do them. But here we go. Step 1. We're going to get rid of parentheses by distributing. And we saw that one a couple times already. This is the distributing, drawing the rainbows and multiplying. Step 2, we are going to combine like terms on each side. So that's on both sides of the equal sign. Step 3, we have not actually seen done yet, but step 3 was if there's the same variable on both sides, get rid of the one on the right. The same variables on both sides, dot, 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 get rid of the one on the right. Step 4, now we're down to a 2-step. These are the last 2 steps. So step 4 is get rid of other terms. Get rid of other terms by adding or subtracting. And lastly, step 5, get rid of coefficients by multiply or divide. Alright, so today is going to be focused on this area. If you have variables on both sides, what do we do? In fact, that's the name of the lesson, variables on both sides. So let's see. I'm going through the checklist. Now you have it on your paper so you can still see it. I might flip back and forth. We have first, no parentheses. Step 1, done. Step 2, combine like terms on each side. Well, look at this side over here. There's nothing I can combine together. I look at the other side. There's nothing I can combine together. Step 2, done. Step 3, if you have the same variable on both sides, they're on both sides of the equal sign, get rid of the one on the right. And I guess I could always add a little something in there. By plus or minus. The way you get rid of it is it can be an add or subtract. We want this thing to be 0. Well, to make that piece go to 0, we need to subtract 11k. Think, 11 minus 11, 0. On this side, when we subtract 11k, we get 3k. And now, it's the same stuff we did in the last lesson. This is actually 2 lessons ago. This is just a 2-step. My variable's being multiplied by something and added by something. So you get rid of the add and subtract first, minus 55. We get 3k equals, let's see, 939. Divide both sides by 3, and k equals 13. Letter be? I do have parentheses. So the first thing I have to do is distribute them. 2m plus 10 equals 4m plus 18. Okay, combine like terms. I do not have anything to combine on either side. So step 2 is done. Step 3, if you have the same variable on both sides, I do get rid of the one on the right. So I'm going to minus 4m because this top one is positive. So 4 minus 4 is 0. Minus 4m here gives me a negative 2m. And we write down the rest of the problem. Let's see. Now we're down to a two-step. So my variable is being multiplied or added. Get rid of the add and subtract first. So I minus 10 minus 10. Negative 2m equals 8. Divide by negative 2. Divide by negative 2. And m equals, see, cancel, 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 cancel. M equals 8 divided by negative 2 is a negative 4. Alright. Let's keep going. Letter C. Next example. I'm going to need more space than that. No, there's no parentheses to distribute. There's no like term to combine. There are variables on both sides. So get rid of this one. Minus 10. Minus 10n, I should say. 7n minus 10n is negative 3n. Write down the rest of the stuff. I need to add 5 to get rid of this minus 5. Minus 3n equals 18. Divide by negative 3, divide by negative 3 to get rid of this multiply. And n equals 18 divided by negative 3 is a negative 6. And lastly, letter D. Ooh, ain't he pretty? Let's see. Well, let's start by distributing. This distribute looks easier. That gives me 5n plus 10. Now, if I do this distribute, it will actually work out okay, and I will get not fractions. So let's do it. This times this times that. So this times this gives you, if you want to do your math off to the side, 3/5 times 5 over 1. 3 times 5 is 15. 5 times 1 is 5. 15 divided by 5 is 3. 3/5 times 10. So 3/5 times 10 over 1. 3 times 10 is 30. 5 times 1 is 5. 30 divided by 5 is 6. So this is my math of what I'm doing this fraction here. Let's see, nothing to combine together, but I do have variables on both sides, so I minus 5n on this side, and minus 5n here, giving me 3 plus 1n equals 10. Let's see, get rid of the add and subtract, so I minus 3 here, minus 3 there, 1n, which again, if you remember from previous lessons, if you have a 1 in front of a variable, that 1 is not doing anything. You can literally just write this thing as n, and we know it means there is one of them there. Okay? So that's where the 1's disappearing to. You just don't need to write it. If there's one variable, you don't need to write the 1. On this side, you get 7, and guess what? We're done. The variable's by itself. Okay? So that is what you do if you have variables on both sides. Now, I will tell you there's going to be some tricks coming up later on, but for the most part, they're not that bad. Please try these 4 problems, copy them down on your paper, pause the video, do them, and when you're ready to continue, hit play, and we'll go through them together. So let's see what we got. Letter E. Let's see. There's no parentheses. I do not have to combine like terms. I do have variables on both sides. I'm going to get rid of this one. Minus 7k gives us a negative 2k minus 8 equals 18. Get rid of the add and subtract. So I'm going to plus 8 and plus 8. These cancel. We get negative 2k equals 18 plus 8 is 26 times by negative 2. So we divide by negative 2, divide by negative 2. K equals a negative 13. Letter F. There's no parentheses. There's no like terms on either side. I do have the same variable on both sides, so I get rid of this one. 8 minus 8 is 0. 2 minus 8 is negative 6. The way we get rid of this plus 9 is we subtract 9. Subtract 9. These cancel. Negative 6b equals negative 18. The way we get ready times by negative 6 is we divide by negative 6. Cancel, cancel. B equals positive 3. Alright, letter G. I do have parentheses. Distribute. 3h here, 15 there, equals h plus 5 there. Alright, do not have like terms on either side. I can't combine any of this stuff. I do have the same variable on both sides, so get rid of this one. We get negative 2h plus 5 equals 15. Now we finish solving. Get rid of the add and subtract, so I minus 5 minus 5. Negative 2h equals 10. Divide both sides by negative 2. Cancel. H equals 10 divided by negative 2, which is a little sloppy. Divide by negative 2 is a negative 5. And letter H. Let's see. This distribute will actually work out fairly well, so we could do this. Times 1/2 of 8. Just think in your head, what is 1/2 of 8? 4. 1/2 of 16. 8. That's the distribute. Okay? Now, let's see. I don't have any like terms. I don't have any like terms. I do have the same variable on both sides. So if I minus him, let's see. That gives us a negative 3c minus 8 equals 16. Plus 8 to get rid of the minus 8. Negative 3c equals 16 plus 8 is 24. The way we get rid of times by negative 3 is divide by negative 3. Cancel. C equals 24 divided by negative 3 is negative 8. All right. Hopefully you had some success at that. If not, we have 5 problems out of the textbook for you to try. These come from page 155, numbers 1 through 6. I have them up here so you can see them, copy them down in case you don't have your textbook with you. But please give them a try on scrap paper, on your note sheet someplace. Pause the video and we'll go through them together. Okay, let's see what we got. Number 1. 24 minus 3m equals 5m. Well, I don't have any parentheses. I cannot combine anything on either side. I have the same variable on both sides. So we subtract this one, subtract that one. And for those people who actually who are more experienced at this might think that I'm doing this problem the long way, and I actually am, but I want to stick with the rules we used. 24, and this gives us a negative 8m. Now, the reason why I wanted to go this way, what I call the harder way, is because of this. A lot of times when somebody says, okay, 5m and they minus the 5m, they don't understand that this gives them a 0, just literally the number 0. A lot of times people go, oh, I don't know what to put over there, so they just kind of leave it blank. 0 is a number, and it's a valid answer whenever you do any math. Okay? Now, this is not a minus 24. It is a negative 8. So the way we get rid of this positive 24 is we subtract it. We are not going to add 24. 24 minus 24 is 0. 0 minus 24 is negative 24. Divide by negative 8. You should have a good idea what's going on at this point. M equals 3. Number 2. 20 plus c equals 4c minus 7. There are no parentheses. I cannot combine anything here. I cannot combine anything here. So there's no combining like terms. Step 3, get rid of the variable on the right. That would be him. Minus 4c minus 4c. We get 20 minus 3c equals negative 7. Same thing as last problem. This is a positive 20. It is a negative 3. The way you get rid of the positive 20 is you have to subtract it. Negative 3c equals negative 27. All right, times by negative 3, so we divide by negative 3. And c equals negative 27 divided by negative 3 is a positive 9. Nine minus 3k equals 17 minus 2k. No parentheses. Nothing to combine here, nothing to combine there, so there's no combining like terms. Step 3, get rid of the variable on the right-hand side. So I'm going to add 2k, add 2k, 9. This gives us 1k. So I'm just going to write k. Know that there is a 1 there. It is 1k. Get rid of your add and subtract. So we're going to minus 9, k equals 17 minus 9, 8. And that would be done. My variable's by itself. That's our goal. Okay? Make sure you have that down. I'm going to erase to do numbers 4 through 6. All right. Number 4. We'll change to black. Why not? 4 says 5z minus 2 equals 2 times 3z minus 4. I do have parentheses. Yeah, I can talk. Multiply, multiply. That gives us 6z minus 8. 5z minus 2. I can't combine anything here. I can't combine anything there, so there's no combining like terms. I can get rid of this variable on this side because I've got 2 of them, so minus 6z minus 6z. This gives us a negative 1z minus 2 equals negative 8. Plus 2 to get rid of the minus 2. And negative 8 plus 2 is a negative 6. Now, this is something that some people lose track of. They forget about this negative sign here. They think, oh, okay, that's just 1z, and then just say, okay, z equals negative 6. But that's not true. With this negative sign out front, you actually have to do this division to get rid of the negative. So this says negative 1 times z. So when we divide by negative 1, the negatives cancel. Now the z is by itself. Divide by negative 1, the negatives cancel. 6 divided by 1 is just 6. Three minus 4a equals 5 times a minus 3 parentheses, distribute, we get 5a minus 15 equals 3 minus 4a. Nothing to combine. Variables on both sides, get rid of the 5a. Minus 5a gives me 3, and that's a minus 9a. Negative 4 minus 5 is negative 9. And this is a positive 3, a negative 9. So the way we get rid of a positive 3, this other term, so we have to minus it. So negative 9a equals, this is now a negative 18. And divide by negative 9. Divide by negative 9. A equals 2. Negative 18 divided by negative 9 is a positive 2. And lastly, number 6. 8y minus 6 equals 2/3 6y plus 15. This distribute will work out for us. By the way, here's how you can tell. This denominator, I look to see if this denominator can go into these other numbers. 3 goes into 6, 3 goes into 15. That's how I know this is going to work out to be whole numbers. So when I take 2/3 times 6 over 1, 2 times 6 is 12, 3 times 1 is 3. 12 divided by 3 gives us 4. 2/3 times 15. 2 times 15 is 30 over 3, which is 10. On the other side, 8y minus 6. All right. We do not have anything to combine on either side. We have the same variable on both sides, so we have minus 4y here, minus 4y there. These cancel. We get 4y minus 6 equals 10. Add 6, 4y, come on. Y equals 16. Divide by 4, y equals 4. So, we've seen now variables on both sides, 1, 2, 3, 4, 8, plus another 6, like 12, I can count, 14 problems we've seen now with variables on both sides. Hopefully in these 14 problems you've seen it's pretty much the same thing over and over and over and over again. You just go through the same steps. Sometimes they're a little bit different, sometimes they're modified, but it's really, you follow those same 5 steps in order, and it solves all of the problems for us. Now, the next example we're going to see here is what happens if there's no solution. What happens if when you have your variables on both sides, so let's just walk through this one for the first step. We distribute, we get 10x plus 5 and 10x plus 2. Now we've got the same variable on both sides, the exact same variable. They're both positive. Now, if I would subtract this one, which would be the next step in this problem because there's nothing combined on either side, so this cancels out. If I subtract 10x here, watch what happens. I get 5 equals 2. My variables canceled out. There's no more x's left in this problem. I have 5 equals 2. And the first thing you should be going in your head is, what? That doesn't make sense. Well, the reason why we have 5 equals 2 and no variable left over is because this problem actually has no solution. There is absolutely no number you could plug in for x that will make this side equal to this side. Now, let me show you why. I'm going to go back up to this step here before I canceled out. So this was 10x minus 5 and 10x plus 2. Now, think about this. Can you think of a number where you multiply it by 10 and then subtract 5 and take that same number times by 10 and add 2 where those two answers are the same? Think about it. What number can you have if you minus 5 to it and plus 2 to it, you get the same number? Nothing. Nothing works out that way. That's why when you canceled out your variables, you get this crazy thing which does not work, and the problem has no solution. There's nothing that works in that problem. Okay? Now, the other option, if we would distribute this problem here, we get a negative 8, we get plus 12x equals 12x minus 8. Something look familiar? Look, 12x, 12x, minus 8, minus 8. When I subtract 12x on both sides, these cancel. This side cancels. I get negative 8 equals negative 8. No matter what number you plug in for x into this problem, you will always get a solution. Every single number will work. You pick 1, it works. You pick 5, it works. This is actually that vocabulary word, an identity. With the equation that's true for all values. I can spell values. U-E-S. I didn't catch that earlier. It's true for all values. It will always work. So when you're solving, if your variables cancel out like they did here, and you have the same number on both sides, if this thingy is true, the answer is all real numbers. Because every number works. I could throw in funky numbers like pi. I could throw in a negative 2.365 over 7. That would work. That would work. Every number would work in that problem. Because no matter what you're doing on both sides, the first thing you're going to do is you're going to times it by 12, and then you're going to subtract 8 from it. You're going to get the same answer. Okay? So, let's see a couple more. And really, those are going to be our two options. We're either going to get no solution or all real numbers in this example. So I'm going to distribute. I get 28c plus 8 equals 28c minus 5. You might be able to see that this guy and this guy are going to cancel. You're going to be left with an 8 equals negative 5, which is not going to work. So this problem is probably going to be no solution. But let's actually finish our work to find out. Cancel. 8 equals negative 5. And does 8 equal negative 5? No! So there's no solution. Letter D. Distribute. We've got 12g minus 6, 12g plus 6, minus 12g here, minus 12g here, cancel, cancel, 6 equals negative 6. Is 6 the same thing as negative 6? No! So there's no solution. Okay, so we did 4 together. Please try these 4, and yeah, I had them a little staggered because some of these problems are a little bit bigger. But please try these 4 problems right now. We'll go over them together. Pause the video when you're ready. Hit play. Alrighty, let's see, letter E. Distribute. We get 3x plus 9. 3x plus 9. Now, you could honestly stop right here. Because you have the exact same thing on both sides of the equal sign, you know that this is going to be all real numbers. This is why it's called an identity. Look at this. It's almost like having a mirror. This guy's looking at himself in the mirror, and he sees himself back. Okay, there's our mirror. 3x plus 9, 3x plus 9. That is why it's called an identity. It's like looking at itself in the mirror. Letter F. 5x plus 3x. Ooh, combining like terms. We haven't seen it combining like terms yet today, but we have to combine those two things together. They're on the same side. We can add them. 8x. 2 times 4x is 8x. That's another identity. That's another mirror. Look at that. So this is all real numbers again. because no matter what you would plug in for the variable, you're always going to get the exact same number, so every number works. Letter G, distribute, distribute. That gives you 4x plus 6. On this side, I can combine like terms. I've got a 3x here and a 1x there. 3x and 1x is 4x. 5 just comes along for the ride. All right. Now, I've got the same variable on both sides. This is not the exact same thing. I've got a plus 5 here and a plus 6 there. So if I minus 4x, cancel, cancel, 5 equals 6. Nope, no solution. And lastly, letter H. So distribute, distribute. That is 4x plus 20 minus 1, 19 plus 4x. I can combine like terms. 20 minus 1. I can do that math. 20 minus 1 is 19. Now, this is another example of an identity. Now, you might say, well, these numbers are backwards from those numbers. Doesn't make a difference. All that matters is I have a positive 4x, positive 4x, positive 19, positive 19. The order of the terms does not make a difference. This is all real numbers. If we would subtract 4x, we can. Minus 4x, really tiny. We get 19 equals 19. Yeah, it's all real numbers. All real numbers. All right. So, those are those 4 problems. The very next thing is just 2 more problems out of the textbook, and then we are done. I lied, 3 problems. Please do these 3 problems. Pause the video when you're ready, hit play, and we'll go through them together. All right, let's see. We've got, actually, I can do the problems right there. I don't need to rewrite them. I'm going to distribute. Distribute, we get 9z plus 27, 9z plus 12. I've got the same variable on both sides. If I minus 9z, these cancel out. Those cancel out. 12 equals 27. Nope. 12 does not equal 27, so this is no solution. On this side, let's see. We've got 7w plus 1, 8w plus 1. If I minus 8w, these cancel. These do not cancel. One thing that I see a lot in the classroom is students think that just because we're working at questions that have like no solution and the stuff cancels, that everything's going to cancel now. No, just do the normal math. Think about it. 7 minus 8 is not going to be a 0. It's going to be a negative 1w. Add 1. Oopsie, no, not add 1. It's already plus 1. If I would add 1 to it, 1 plus 1 would be 2. I don't want 2. I want 0. So I subtract 1. Subtract 1. Negative 1w equals 1 minus 1, 0. Still got to get the w by itself. So you divide by negative 1. W equals 0. 0 is an answer. Don't be afraid to have the number 0 as an answer thinking, oh, I can't have that. You can, and it works. Lastly, number 10, which, by the way, I don't know if you folks saw the directions. It says solve the equation if possible. So that means some of them are possible, some of them are not possible. I don't know at the time which one letter 10 is. I don't know if 10 is possible or impossible. But let's find out. We get a 6a here plus 6. We get a 6a here plus 6. It's identical. Both sides are exactly the same, so this is an identity, which means the solution is all real numbers. Nice and easy. All right, so what I'd like you to do, at the bottom of your note sheet in the summary box, answer this question. How do you know if the equation has no solution or all numbers as a solution? Pause the video, write down your answer, and if you can't answer this question, then you did not understand the whole second half of the lesson. You don't understand why we did these things. How did I get things like no solution, all real numbers? Think back to these problems. Why did we get all real numbers here? Why did we get no solution there? How do you know if an equation has no solution or all real numbers as a solution? Okay, here's my answer. If you didn't put yours down yet, pause the video and put yours down. How do you know? Well, you know if the variable cancels out, on both sides, dot, 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 if you get something like 3 equals 3, that is all real numbers. If you get something like 5 equals 8, where the numbers are not the same, that is no solution. But the first thing to make this true is that if the variables cancel out on both sides. If the variables do not cancel out on both sides, then you're going to get one solution, like we did in the first half of the lesson. All of these problems up here, the variables did not cancel out on both sides. I still had a variable. So we just solved it like normal. We got one solution. So we've seen where you can get one solution. We've seen where you can get no solution. And we've seen where every single number is a solution. All right. Now, there is the homework. It is page 157, numbers 2 through 28 evens. This has been lesson 3.4. Thanks for watching.